So I've solved the Cartesian stuff well enough for now. So we just send some commands here. So I told it to go to 0, 0. There we go. And now let's go to Y10. Yep. Y30. So Y negative 30. So it always tries to move the smallest amount possible. And due to some weird maths, some weird trig, I've worked out that it doesn't matter, like when I calculate the correct angles for that axis and that axis to get that XY position, the axis angles are interchangeable. So if I disconnect the power here, so that is right now at x equals 0, y equals negative 80. And that has given me two angles for that to get to that arrangement, which is 355 degrees for that axis and 184 for that one. But if I flip those and put 355 on that and 184 on that, what I get is the same resultant point in space, the same xy coordinates. It doesn't matter which of these axes gets that angle applied to them, the end result is the same. So I just look at what angle this axis is currently at and flip the angles that I feed to the stepper controller code and just pick whichever one is smallest. So this angle moves the least, and that gets to the smallest angle between them, or the smallest motion to get from one position to another. It's not in a straight line, so if I go from there and then I tell it to move to there, it doesn't make it in one smooth, it doesn't make the movement in one smooth motion necessarily. Usually what it does is it turns and then does a little correction on the other axis. And that's because in order to maintain the angle relationship between this arm and this arm, both steppers need to be turning, and at present I've only got one speed for the steppers to move at. So when it's trying to move directly between 2 points, it should actually be moving one of the steppers faster than the other, because this arm has to do its driving in order to get from its angle, its old angle, to its new angle, but it also has to do extra driving because it has to account for the first arm moving it around. You see how arm 2, the thinner one, stays fixed at a given angle relative to the table. So in order for that to change, this stepper needs to also spin to maintain a fixed relationship between these two arms. So it's a tricky proposition, but at the moment I'm solving that by feeding it G-code that has sufficiently small moves, so it moves there, 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 and the end result is a straight line. I don't know if I'll bother making the G-code to reality translation smarter. We shall see, but I think that software is good enough for now. And I can quite easily fire new patterns into it via, send new G-code to it via MQTT, which has sped up testing a hell of a lot. So let me just zoom up and I'll feed that one to it, and away it goes. So I've had the power off and I was moving the arms around willy-nilly, and it hasn't homed since I've done that, so it has no idea where it is. So I might send it a pattern that has a home signal in it. There you go. So it's homing the x-axis now, or the first arm. Now it homes the second arm. And now we're all back in sync. So that's 0, 0. That's 0, 400. Back to 0, 0. 0, negative 400. And then back to 0. And it carries on. I've implemented this non-standard J0 G-code for jumping to instruction 0, which is extremely handy for testing. And I've got a bunch of debug information coming out here. Right, that's where I'm up to. Bye bye.